Alright, we're live. Alright, this month, like Kira said, we were expecting to have another talk, so I don't have a lot of content prepared, but I did want to speak about the module support in Go 111. Just by like show of hands, who here has used either Vigo or the module system?
Vigo.
I'm all over both.
Okay. So that's good. A lot of people still haven't used either, so this should be somewhat educational. So just to start off, I just wanted to say, like, I'm not an expert at this. I have not used Vigo at all in any projects, and I've only recently been tinkering around with modules just on my own time, so I haven't really used it for any projects at work or any personal projects for that matter. So I'm not an expert, so take all this with a grain of salt. Let's see. My general feel for like modules is that it's kind of an improvement from the current state of dependency management Go, which is not saying much, but it's definitely welcome. So what is a module? Module is a tree of packages that share a common prefix and are versioned together. So something like github.com, JSON Keene, my foo, like that would be the module prefix, and then underneath there you could have however many modules you want, or however many packages you want. Usually this is like a one-to-one mapping to a Git repo, but there is support for having multiple modules in a single repo. I didn't look into that because I wasn't really interested in that, but I did see it mentioned several times, so I just wanted to call that out. So modules in 111 include changes to the Go tool chain as well as this new concept. So when you do things like go get or go build, they have different behavior with this module support than what you might be used to. So the old tools act a little bit differently.
How do they decipher that difference? Is it because there's a file that indicates you're using modules, or is it because of the...
Yeah, so I have a little bit of a section on that later, but I'll cover it now since you asked. So the way that you kind of declare that you're using modules is by one of two mechanisms. The first is use an environment variable, say go 111 modules equal to on, I think.
Yeah.
That's only useful if your source code is in the Go path. The other option is to just pull your source code out of the Go path, which I highly recommend. And then if you have a go.mod file somewhere in the ancestry of your directory, then the Go tools will recognize that as being a module, and then it'll switch over to the new behavior. So one of the key kind of concepts that Russ Cox was discussing in all of his blog posts, I'm basically just gonna do the highlights of all of his blog posts here. So one of the main concepts is the import compatibility rule. So prior to Go 111 modules, import compatibility wasn't really a rule, it was more like a suggestion in the Go docs. So now this is becoming an official rule. So the rule is if an old package and a new package have the same import path, the new package must be backwards compatible with the old package. So no renaming symbols or doing anything that might break your users. If it's the same import path, the code shouldn't break. So that's kind of something that, obviously that's like community, cultural type thing that we have to adopt. It's not something that we can just wave a magic wand and make everyone behave that way. So, you have a question?
Yeah, so by import path, do you mean at the top of the file or in the directory path that with Vigo includes the version number?
Yeah, so it's the import path is the string that you put in next to the import statement.
Okay.
So if that's the same across revisions, it has to be compatible, backwards compatible, not forwards compatible. So yeah. So you might ask, well, how do we introduce break and change? I like to break my users. So major versions are how you break APIs in Semper, and Go modules use semantic versioning. So in this situation, how does that map to import paths? So major versions above V1 are included in the import path now. So you can have these are some examples here. I don't know if you can see that. But, so if you're working on a library that's pre 1.0, you just use the name of your module. That's your import path. If you're working on post 1.0 as well, same thing. You don't include the v1 suffix. If you're working on v2, v3, anything after v1, you must include the version, the major version number in your import path. So that's how Go kind of gives proper recognition that these different major versions are actually different things entirely. They're no longer like similar things. They're entirely different. Let's see. So yeah, one of the consequences of this is that your final program can link against two different major versions of the same library. So, or n versions of the same library. So I can have v1, v2, and v3 the same package built into my binary and be calling in and using, data and reference things in all three of those. So that's kind of interesting. So using modules, like I said before, modules are defined as a go.mod file, being somewhere in the ancestry. And the main thing that this module file contains is that path prefix. So you declare that as the module path at the top of the file. The other thing is all the dependencies that you have, but the tooling kind of helps you manage that, so you don't really need to manually edit that very often. So we already covered that. Cool, so onto my demo. If anyone has any questions at all during this demo, just let me know. Stop here. So I'm just gonna use the Go 1.11 RC1 image. So all the betas, they didn't have any Docker images, but now that it's on RC1, they have a official Docker image for it. So if you want to play around without messing up your development environment, you can just use the Docker image. So most of the tooling is under Go mod. So just run that. You can see there's a bunch of commands here. So this is the first command that has like nested subcommands. So Go mod download. That's kind of like new. So yeah. The first thing you want to do, let me explain this Docker run real fast. So I'm just volume mounting my current directory into this path here called mymodule/command. So this is outside the Go path. All Docker images that Go publishes, the Go path is /go. So you can see I'm in there right now. I can probably echo Go path, and you can see it's /go.
Can you underscan just a little bit, Jason, or like when your screen is getting cut off?
Yeah, we can do that. Is that better?
Well, thank you. Great.
Let me make sure. Yeah, you don't see the percents yet. Okay, cool. All right, so the Go path is set to /go, just so you have that for reference. And then we're going to cd over to my module command. So this is where I volume mounted all the code. So there's not much code to this demo. It's just a main.go, and there's two imports, just spew, and Russ Cox has this quote library that he uses as an example. So I'm just using that as an example here. So if we do go mod init, and you just give it the, so I'm going to go back to this kind of the module directory here. Say go mod init github.com /mile high gophers /mod demo. So this will create that go.mod. And you can see right now it just says module and then the prefix to all the packages. So yeah. In order to populate this go.mod file, you can do a number of things. You can do go build, go list, go mod tidy is like another way of doing it, go test. So there's a lot of different commands that you can do that will populate this file for you. The idea is that you shouldn't really worry about populating it. It just, as you use these tools, the tools will kind of manage this file for you. So we're going to do a go build, just called a binary demo, and then I'll give it the full path to my package here. So that'll build So it needed to download these dependencies. So at first I found this view package, and by default, when when the tooling discovers that you have a new dependency, it'll go out to the source repo and find all the tags, and basically it takes the latest tag. And if you don't have any versions, like tag versions, it'll just take like the latest of the default branch. So it'll use that SHA. It has something, I forget what they call it, but it's like the version will be v0.0.0 and then contain a timestamp and then the hash, or a part of the hash. So yeah, you can see that here. So this text library doesn't have any tag versions, so it kind of just made up a version. So let's see here. Some other things. Actually, let me get out the Go. So,
if you specifically wanted to use Ghost View version 1.09, is there something you can denote in your import statement to make Go like pick that up, or do you have to specifically like manually manage the Go.dat file?
So the two ways I've seen to do it is to use GoGet. There's like syntax where you do add and then the version that you want, and you can take things like latest or a hash or a branch. You can do a branch,
And then we'll rewrite your .dat file?
and yeah, that will resolve into a concrete like version, and then put that into your go.mod file.
Okay.
So that's one way I've seen it. The other way is just to put that same, they call it like a module query. If you put that in your go.mod file itself, if you edit it manually, and then you run any of the tooling, it'll resolve it for you and rewrite it. As far as putting in an import statement, I haven't seen that. But I can't speak to that because it'd be cool if they could do that, but I don't know if they do that or not. So after running that build, you can see it populated the go.mod file with a bunch of requires, and they resolved to the latest versions. So along with this go.mod file is this go.sum file. I believe in Vigo, I played around a little bit with Vigo. I believe it was optional in Vigo, so I'm glad that they're actually generating it by default in modules. So what this sum file does is basically whenever it like sees dependency when it's building or whatever, it'll generate like a cryptographically strong hash of that module and store that in this file, so that in the future, if like say if I went and I tampered with the file system here locally and like changed some bits in the source code, if I try doing a build, I believe a build by default will verify, but there is an explicit command go mod verify that like will check this sum file and make sure that the hashes match. So with these two files, you really have strong reproducibility in your builds. Not only do you have like a deterministic set of like requirements that will always go to the same versions when it gets resolved, but you also have these cryptographic SHAs so that even if you request the same version, if you get the wrong bits out, it'll let you know. So just cat out that real fast so you can see what it looks like. So yeah, nothing surprising. It's import path, or the module path, the version of the module, and then I think each one is the name of the hashing algorithm, and this is some type of base64 encoded hash. So nothing spectacular there. One thing is that this file kind of grows over time. Just kind of a historical record of all the packages your tool chain has kind of seen, or all the modules that your tool chain has seen. So it's just additive. You shouldn't have to go in and like mess with this.
So
Yes.
Is the x.text, is that like a transitive dependency or something like that? Why is that not in the mod file?
Yeah, so all like transitive dependencies, since the algorithm is kind of deterministic, if it can prune those out, it'll just exclude them.
Okay.
Because it's not needed for the algorithm, the minimal selection versions algorithm to actually work. You can put them in there, but it'll just strip them out because they're not needed. Good question. But yeah, text is definitely, I think text is a dependency, or is a dependency of sampler, which is a dependency of quote. I think that's how that works. Actually, I think you can run go list m all, and and this will list out all your modules. And I think there's like a go mod y. We'll look at that in a bit here. So I'm actually gonna like monkey with this hash file a little bit. So if I cat out the go.sum, you can see I just like put some A's here. So I changed the hash. And so if I do go mod verify, it'll actually complain. It'd be like, well, I originally downloaded this hash, but that's what you're telling me the hash should be. So something's wrong here. Fail to build. So that's really useful. So I'm just going to blow away the sum so it's not valid anymore. Okay, so yeah, to view all dependencies for the module that you're currently in, you just do the go list all -m, and that'll list out all the modules that you're depending against, and that your dependencies are depending against, and so on and so forth. One awesome thing about modules is vendors going away. I don't know if any of you folks have had the pleasure of using like libraries that vend those stuff, and then trying to pass something into one of those vendor libraries, and the type that you had, even though the same version of the library is a different type, and then it's incompatible. You can't reach into it sometimes. So yeah, all that's going away, but not entirely. There is still a vendor directory that you can have at the top level of the module that's being built. So I guess the idea here is this is more for project-based repos where you want to vendor the concrete resolution of all the source code for your build. I don't think it's intended at all for libraries to vendor. I think just the tooling, the module support is supposed to make vendoring for libraries kind of obsolete. So if you want to populate that vendor directory, you just run go mod vendor. And this is like really fast. Surprise how fast it's running. So that just gives you this vendor directory with all your source code in it. So you can see quote. So just all the files that are part of that one. Let's see. Roll that away. Goodbye vendor. Okay. Okay, so there's also this command go mod y, which tells you why a package was included. So if I run it on the text package or the language package as part of the text module that Dwayne was referring to earlier, actually I just copied it from here. So that'll show you, and I think you can do multiple packages here. So yeah, and then it'll have a comment above like each package. But the only one that we really care about is this language one. So it says, the first line is like a comment. It's like, this package, everything below here is relevant to why this package was included. And then from the bottom up, it'll show you kind of the path that it took of why it's being required. So language is required by sampler, which is required by quote, which is required by CMD. That's useful for like figuring out why something is where your build. Go mod tidy. I've only like played around with this a little bit, but basically when you're running these go commands, like you're running them and it has access to the package that you're running it on. So like if you go build on a package, it's kind of only gonna deal with that package. It's not gonna deal with your entire module. So if you want to update the go.mod file with all the, like say you added imports in 20 different packages in your module, and you just wanna update the go.mod file with all those new imports, you just run something like go mod tidy, and it'll find those new imports and put them into the file for you. Like I said, like if you're using like the normal Go tools, it kind of manages the file for you, but this is kind of like module wide, it'll kind of fix everything for you. So yeah, this is kind of something interesting I ran into. So in our CI, we have like a layer of our Docker image that has all of our dependencies in it, and then the layer after that is where we do our actual build. So basically, we only want to invalidate that layer above if we have new dependencies. So we get to reuse that layer across builds when we're just modifying our code. So in that build where we're just building our code, we don't want to go out to GitHub and download stuff from the internet. So this is really useful. If you do go build mod read only, it'll resolve the dependencies and everything like normal. But if you don't have those things already downloaded, it won't go out to the internet and download them for you. So it'll actually fail the build, which is kind of nice.
So does that mean it would require that you have ran go mod vendor before for the dependencies to be there, or it's up to you to get them there through whatever mechanism?
You could do go mod vendor, but whenever you run any of these commands, the Go tools download the source code to a place, it's in your Go path. So it'd be under Go path /pkg/mod. So we can actually look at that right now. So you can see this is where all the source code is. So when I ran that go mod vendor command, part of the reason why it was so fast is it was just like linking against basically these files. So yeah, it's the main place that things are stored is in this go path pkg mod directory. So in our CI, I haven't converted our CI over to using modules yet, but I imagine the thing that we're going to do is just populate this mod directory using the Go tools, and then just assume that everything's there, and then put that read-only flag in our builds to make sure that we're not, downloading stuff.
Are the subdirectories in this directory hashed or like versioned?
Sorry, was that?
Are the subdirectories in this?
Yeah,
are they versioned to the hash?
Yes, they're. I guess I should just show you. I think I haven't really looked at this a lot, but there are version numbers in here.
Okay, yeah, so they're version to the version at least if they're both, but not hash.
Yeah, I think if you use the hash, it might end up in there, but all the things that I've seen have the actual version number in it.
No, that makes sense, because it just takes the hash of the directory to compare against the hash from the go.dev file, right? Or the go mod file.
Yeah. Let's look at this text thing. So this has that version with the hash in it.
What's cool about that now is your build can have multiple versions of the same library.
Exactly.
In it.
Yeah, multiple major versions.
Yeah.
That's one thing I was kind of confused about before I learned about Vigo and modules, is that I just assumed like, oh, I can have any version floating around in my binary that I want. It's any like major version.
It's not all tagged versions?
No, so you can't have 1.0.1 and 1.0.3, and you can't have both of those in your binary.
So if you change your go.dev file to use view 109, it's going to get rid of 110?
Which one am I using right now? Am I using 110?
You're using 110 right now? Or if you originally used 109, it would blast away 109 and put 110 there?
Well, this is kind of a cache, so it'll land both of those in this like directory structure, but your resulting binary can only link against one of those major versions.
Sure. But if you had two different applications, the caching directory would still have both of those.
Yes.
Those minor versions.
Exactly. Or if you had like just two separate packages in the same module that just happen to not to require different ones. Actually, no, I don't think you can do that. You'd have to have two separate modules in your project.
Sure.
But yeah, the main thing is like major versions are how you break API compatibility, so that's why they allow them to coexist in a single binary. So that's pretty much it for my demo. I have this little blurb here about the MVS, the minimal version selection algorithm. I read over some of Russ's stuff, and it's kind of simple for like dependency resolution stuff, but it's kind of boring to be honest. So I didn't really grok it all, but the main takeaways is that your require statements, you establish the minimum version that you require. So if you're a library and you are compatible with a dependency version 0.1, then you want to put that in your require statement. You don't want to put 0.5, because that kind of limits the choices that this MVS algorithm can make. So as a library author, you set the minimum version that you require. The algorithm will find a set of dependencies that satisfies all the module's requirements. And one unique thing about MVS that I learned about recently is that there's always a solution to MVS, whereas with SAT-based solvers and other type of solvers that are in other languages, sometimes you can get into situations where there's no solution to the constraints that you provided because they're just mutually exclusive. So with a minimum version, like you always have at least one version that is like the solution to the algorithm. So yeah, whether that solution to the algorithm builds or is correct is an entirely different question. So you will run into situations likely where you'll have MVS produce a set of versions for your dependencies that either fail to build or your tests fail. And in those situations, there's capacities in the go.mod file where you can exclude certain versions or actually wholesale replace versions with other versions. So you can say, oh, that thing where you resolved it to 0.1, just use 0.0.9 or something. So you can do those replacements. Questions?
So it sounds like the MVS strategy is to really trying to address the problem with transitive dependencies where you pull into libraries and they pull in the same library but different versions.
Yeah.
And if you always went with latest, then that would make it more probable that your build would fail because it wouldn't be able to select one that satisfied both requirements.
Yeah.
So as a community, all these modules, the ecosystem that is your project needs to use MVS.
Yeah.
Okay.
That's the main intention when you have these diamonds where you have two different packages that require the same package but they require different versions. Like I said before, if they're different major versions, then there's not a problem, but there's going to be a lot of situations where they're the same major version. And in that situation, you have to find a version that's compatible. And so both of those libraries that share the same dependency with different versions, if they just require a minimal version, there's going to be a version that they're compatible with. So yeah, that's basically the algorithm. I mean, it just kind of recursively walks all the modules, collects all the requirements, and then if you have 3 requirements in that list for the same module, it'll just find the one that's the greatest. It's like, okay, that's it. I mean, that's pretty much it. So yeah, the latest version is used by default when you add a dependency, so you get the latest and greatest when you add it, and then as you work on things, as you add other dependencies, they'll get the latest versions, and maybe there'll be a situation there that you have to intervene, but the basic idea from what I understand is that these things don't change. You don't get new versions incorporated automatically. Just because someone published a new version, you don't automatically get it. And that prevents your build from failing unexpectedly. It's like, oh, well, it worked yesterday, I didn't change anything, and now it doesn't work. Like, what happened?
The latest version is used by default. Is that also for transient dependencies?
No, so...
That's only for direct native dependencies.
If I get you, I'll get your latest, but if you declared a requirement...
then it's whatever my MVP is. That's what gets...
Yeah, right. Unless someone else was in...
Has a higher
version. So yeah, one of the advantages of MVS is that it's a really simple algorithm. It doesn't require an NP complete SAT solver, whatever that means. So, it's much simpler to reason about, and it's a lot faster to run, and it's generally the consensus from what I hear from folks that are using it. Like I said before, you have this capacity to replace and exclude incompatible module versions. So one unique thing about that I didn't list here is that only the module that's building can use those capabilities if like your dependency has exclude or replace rules. They're ignored when you're doing your builds. And the reasoning for that is they wanted to establish that your dependencies shouldn't have too much control over how you do your build. They have this minor control where they can establish like a minimal version that they require, but beyond that, they can't tell you can't use a specific version for reasons of like incompatibility. Because if you had one of those situations where you had a diamond and say you have A, B, and C, if B and C have mutually exclusive requirements because of these exclude and replace the rules, then you can get a situation where you can't get a solution to the module resolution. So that's kind of one caveat that I kind of ran across. So yeah, there's been a lot of kind of blog posts and controversy lately around the Go modules and Vigo as well. What do you, like, I seen a YouTube video today, like people picking apart modules and stuff. So anyways, Rust's solution departs like from the way that this problem is solved in other languages. So it is kind of like, why do we need to do this? Why do we need to reinvent this wheel? You know, it's like, this has been solved so many times. Why not just use the solution that all these other languages have, you know, unified around? That said, the dev folks, well, yeah, because of that, the dev folks are justifiably a little bit sour about the whole thing. There's been a lot of criticisms about how the decisions were made, about the MBS algorithm itself, and that work was put into depth and was not like incorporated into the Go tool. I think they had hopes that at least the ideas, if not the actual work that was put into depth, would eventually get into the core tooling, but it wasn't. You just
opened it.
High pressure water.
So yeah, just my kind of anecdotal experience. Most of the folks that I talk to kind of enjoy using Vigo and modules, and I've only ever heard complaints about depth. Again, this is anecdotal, but I've heard a lot of people complain. And I was a depth proponent like last year's GopherCon. Like after that, I was like, everyone should use depth. And then everyone came back to me saying, like, why did you tell me to use this? So a lot of people complain about how slow it is. And I work on Kubernetes stuff, and I ran into a few situations with some of the repos that I work on that I just couldn't get depth to work no matter what. So like, I tried my hardest to get depth to work, and it just was not going to work for me. So that's anecdotal, but that's my personal experience. And then kind of just a final note, the more I learn about modules, the more like I think that they're a home run for Go. Like one of the core tenets of Go from the get-go is like, this is a language that's meant to scale to like huge code bases. And you see projects like Kubernetes kind of struggling with the dependency management. And they're a very large project, but I can imagine larger projects in the future of Go. So we kind of need a package manager, dependency management system that, you know, scales to these massive projects. And the MVS, with the simplicity of MVS, it kind of fits well with that design goal. So I think it's a home run, but only time will tell. We'll see what happens.
So just picking off of what you were saying, so you mentioned that you were using depth for your current project before. Are you using Go modules like for Series C's now, or are you still experimenting?
So the place that I use depth like immediately when it was released, and I had pretty good success with it. That was like a small personal project. For my work on Kubernetes, it was someone else's library. They were using Go depths, and I was like, man, that thing's ancient. Like, why are we using that? So I tried bringing in depth to just replace Go depths, and there was some type of incompatibility that, I probably spent like 45 minutes on it, couldn't figure it out, and moved on. It was kind of frustrating. It's like, why doesn't this work? It's the new stuff, it should work. I don't know if that answers your question.
Well, when we did it, we only had 4 different projects that shared and 3 microservices, and it ended up, and this is back in GoDeps like mid-2016, and it was such a nightmare that the team 6 months later rewrote one of the things in Java so they wouldn't have to deal with Go anymore.
Well, that's not the effect that I think.
But I started playing, listened to Russ Cox's talk and started playing with Vigo and everything else, and I thought, well, Go has so many advantages, and nothing's not necessarily new, but putting it all together in the way that they have, I think that Go's really compelling. And this was the one wart right on the forehead of Go. And I think Vigo kind of just fixes it. So I think it's awesome.
Yeah.
And modules, now that modules are out.
Yeah, one thing that I kind of ran into is I was kind of following some of the content that Russ produced for Vigo and trying to map that into the module support, and like things that kind of changed.
Yeah.
So I think all the stuff that's in Vigo isn't in modules. It's definitely like a subset of what Vigo was. But yeah, I'm excited to like see like all the Vigo things move over. 'Cause there's some stuff in there like I believe it was like testing. Like I wanted to be able to test like all the things that were in my module, but not my dependencies. And like the only thing I can find that's in modules, if you go test -m all, it'll test all of your module stuff, but it'll also test all of your dependencies too. So like stuff like that, like they don't have all that like moved over yet.
So with the kind of decoupling of GoPath from your projects, what kind of new workflows do you see that are more easily facilitated with this tool than previous tool chains?
So one thing that I kind of run into a lot is I work on a lot of different projects at the company I work for, and like we have separate workspaces to isolate the dependencies on each one of those projects. And so this is kind of just a hassle. Like we have to use like stuff like AutoJump to like get into those like source code directories, because it's like so many different nested directories in.
Sure.
And like just like kind of that is kind of a hassle. Having like just like projects directory and then this is where my source code is. That's just kind of nice. So I mean that's nice. I think the Docker files that we have, like the Docker images that we build, I think that'll like be a lot simpler, because right now what we do is we copy over we prepare a workspace outside of the Docker build, and then we have like a multi-stage Docker build where we copy over all the entirety of the workspace into the build image and then do our build. So I imagine like that's probably going to be a lot simpler. Like we have a few images right now where we're using this layered approach, where we have a dependency layer and then we have our build layer. And I imagine like that's going to be like better for our build system. But yeah, I don't know, we'll see.
Cool.
I had kind of a general question because I don't know what a lot of other people are doing in Go. How do you manage build management for your projects, I guess, like bash makefiles, Bazel for bigger things, just to make running the individual commands over systems of projects easier?
Oh, kind of like a command runner type thing?
Yeah, so instead of just, like, when you're going to production, instead of just typing, and building, setting it up so that something bigger can manage your builds.
Yeah, so we use a continuous integration, continuous delivery like system. We use
A SaaS or?
we use something called Concourse.
Oh, nice, yeah. So fly and.
Yeah. So we just define this is how you build the images, and then this is how you deploy them in production. And so we push, and we have some testing suites that we gate or release by, and whenever something passes there, we just deploy it to production.
Anybody else proud of their build system?
There's always a little bit of bash.
Yeah.
Together.
The last place I worked was a lot of Jenkins, so it's Groovy, and then using Docker as a build environment for building Docker images.
That's what we did, is have Docker CI containers and have a general pipeline that would use a CI container, and then you had kind of a package.json system. So in your Jenkins file, you just add in there and give commands for each stage. That was one of the things. Tried going back to make, and what I figured out, because I haven't done it for a long time, is it's really just bash, only a lot more complicated. Right? Unless you're working on C projects or C++ projects, because just managing the Docker files, like building one and standing it up and running tests, really just because now you introduce another layer where you have possible unfolding. Right, you have the make layer that takes your statement and will do variable replacement, and then you can have two layers in bash, right? So I tried Bazel for about 2 days, and a pain in the butt, I just thought, you gotta work at Kubernetes scale perhaps before that level of effort and complexity pays off, because no doubt it's fast and robust, but learning curve.
I'm not sure everyone on the Kubernetes project likes Bazel even then. So.
Yeah.
Okay, because it's not, the curve is like this. It's kind of like you're running along.
That's good feedback though. You should like open issues on that. I'm sure they want to improve that.
On what? Bazel?
On Bazel, yeah. I mean, just
You know, I hadn't really thought of that because that was the early problem with Kubernetes. Is really everything was
should be
Kubernetes
easier
the hard
to
way,
use.
right?
Easier to use for sure.
And they really fixed that a lot. So, yeah.
I mean, that really
Give
goes for
back.
everybody.
Don't just complain.
If you think something sucks, like go tell them, and they'll be like, "Oh, that really sucks. We can fix that."
So I assume the environment variable, that's just, it'll go away at like 12 or something like that.
Yeah, it's probably gonna be like the Go vendor experience environment variable will probably just disappear at some point. There's a lot of stuff that I saw that they're like suggesting that they're gonna remove at some point, which is kind of funny because like one of the things I learned from like doing all this reading was that like you never break, you never remove stuff. It's okay to leave it around, you know, like, just don't break your users. But I mean, that's kind of what they're doing here. They're removing like the old functionality, but I guess maybe it's different for the actual language, the host language.
Is it Go list that ignores the vendor directory? Like when you're trying to get a list of your packages
Currently,
and imports, yeah.
or
currently.
with modules. So I don't use vendors at all, so maybe someone else might know. Yeah. I didn't, well, we can kind of test it out here.
One of my dreams, though, is to remove the vendor directory, or at least be able to use it for your own stuff, I guess. Because right now it's sort of this magic directory that you can't touch, and you have to work around with, you know, linting or some automatic tools that don't know to ignore the folder.
Oh, Go list does not ignore your vendor.
Okay.
I know that because I ran into that.
but I think one of those is supposed to.
You can pipe it into
okay.
and like pull the
And remove it that way.
vendors out that way. That's the way I've done it in the past. And there, I think it was actually Russ. There's one of the core team members like posted like a little snippet for you to effectively ignore the vendor with your Go list command. But we can experiment with it right here. So if we do Go mod vendor, we have our vendor directory and then Go list dot slash dot dot. Yeah, it doesn't list the vendor. Dash M. Okay, they don't like that. Relative to that.
Oh, if you use an absolute path.
Maybe foo slash dot dot dot. Yeah, so it's not showing the vendor. So maybe that's the way you're supposed to run Go test now. Go test and then give it like Go list dash M foo or something.
I think that changed in 1.11 as well, or maybe 1.10, where Go tests started to automatically ignore the vendor directory. You didn't have to,
Oh,
because you used to have to list it out and prune out everything in vendor when running Go test, but that changed in 1.10, I think.
I learned recently that the Go toolchain is not subject to the same compatibility, the backwards compatibility promise. I always thought like it's just anything Go is like going to be compatible.
It's
for
a language compatibility.
Yeah,
source code.
the tool chain will break you if they want.
Yeah. I didn't realize that they didn't have any compatibility guarantees for the tool. That's good.
It's good enough.
Cool. Any other questions? No?
Awesome. No, thanks a lot.
Really, thank you.
Matt wants to
I got like 5,000 words.